Data isn't always just numbers. Sometimes it's categories like colors, names, or even emotions. But how do machines understand these non-numerical values? That's where one-hot encoding comes in. It helps convert categorical data into a format that machine learning models can actually process. Welcome to day 24 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. In this video, we'll break down one-hot encoding, what it is, why it's essential, and how to implement it seamlessly in Python. By the end, you'll see how this simple technique can make a huge difference in training your machine learning models. Let's bring in the essential libraries: pandas for data handling, NumPy for numerical operations, and matplotlib with Seaborn to make our visuals pop. Time to load our dataset. With just one line, pandas reads the CSV and transforms raw data into a structured format we can work with. Let's take a quick peek. Head cross shows the first few rows, giving us a glimpse of the data, while info reveals column types and missing values. Here we fill empty embarked entries with the most frequent value, ensuring our dataset stays clean and consistent. Let's clean up. We're identifying and dropping columns containing 0 in their names, removing unnecessary data to keep our dataset lean and efficient. Now let's convert categorical data into a machine-friendly format. We initialize one-hot encoder, specifying key columns like sex, embarked, and P class, while avoiding redundancy using drop equals first. We apply one-hot encoding, transforming categorical columns into numerical form. Get feature names out ensures clear column names, and we neatly store everything in a new data frame for seamless integration. Now, we remove the original categorical columns and seamlessly merge the encoded features with our dataset, ensuring it's fully numeric and ready for modeling. Here, we separate features and target, dropping irrelevant columns like passenger ID while keeping survived as our target, ensuring the model learns from meaningful data. Time to scale. Standard Scaler standardizes features by removing the mean and scaling to unit variance, ensuring our model isn't biased by varying feature magnitudes. Before encoding, let's explore feature relationships. A heat map visually highlights correlations, helping us understand which features influence each other and guiding better pre-processing decisions. Let's check for outliers. A box plot reveals value distributions, highlighting potential anomalies in our dataset before encoding. Rotating labels ensures clarity for better interpretation. After encoding and scaling, let's reassess feature relationships. This heat map helps us spot new correlations, ensuring our pre-processing steps improve data representation for modeling. Now let's inspect the scaled features. This box plot helps us identify outliers and confirms that our data is properly standardized for optimal model performance. Time to split. We reserve 20% of the data for testing, ensuring our model learns from training data while keeping a separate set for evaluation. Let's build our model. We're using a random forest classifier with 100 trees. leveraging ensemble learning to improve accuracy and handle complex patterns effectively. Now let's see how well our model performs. We predict on test data, calculate accuracy, and analyze precision, recall, and F1 score using a classification report for deeper insights into model effectiveness. And that's how we transform categorical data using one-hot encoding. Now, our dataset is fully prepped for machine learning models, but one-hot encoding isn't the only way. What if we need a more compact representation? That's where label encoding comes in. Curious to learn more? Click on the screen to watch the next video where we break down label encoding and when to use it. See you there.